Deep in the constellation Sagittarius lies a secret, so massive it warps the fabric of space itself. For thousands of years, ancient stargazers watched this patch of sky without ever suspecting what hid there. Astronomers pointed telescopes toward the galactic center for decades before anyone understood what was staring back. In 1931, engineer Karl Jansky detected mysterious radio static coming from the direction of Sagittarius. He had no idea he'd just stumbled onto the first hint of something monstrous at our galaxy's core. Radio astronomy was born from that discovery, opening a window humans never knew existed. For decades, scientists suspected something dense and powerful sat at the Milky Way's exact center. But visible light couldn't penetrate the thick clouds of gas and dust blocking our view. Only radio waves and infrared light could slip through that cosmic fog undisturbed.
In 1974, astronomers Bruce Balick and Robert Brown detected a compact, unusually bright radio source.
It sat precisely at the dynamical center of our entire galaxy, unlike anything catalogued before. Nobody yet knew whether this strange object was a star cluster, a nebula, or something stranger. In 1982, astronomer Robert Brown gave this mysterious source an unforgettable name: Sagittarius A. That asterisk wasn't decorative. It marked the object as excited, energetic, and scientifically significant. Still, proving what Sagittarius A actually was would take another 2 decades of painstaking observation. 2 rival teams of astronomers began racing to solve the mystery, using different telescopes entirely. The other, led by Andrea Ghez, used the massive Keck telescopes high atop Hawaii. Both teams needed a technology breakthrough just to see through the galaxy's blinding starlight and dust. That breakthrough was adaptive optics, a system correcting for Earth's turbulent, blurring atmosphere in real time. Suddenly, astronomers could track individual stars swirling incredibly close to the galactic center.
One star in particular would become the key to unlocking the entire mystery.
Astronomers named it S2, and it orbited something invisible with terrifying speed. Year after year, both teams charted its position, plotting an orbit unlike any star nearby.
S2 completed its entire orbit in roughly 16 years, a blink of an eye in cosmic terms.
At its closest approach, the star raced through space at several thousand miles per second.
No ordinary object could force a star to move that fast without being unimaginably massive. The math was becoming impossible to ignore, and it pointed toward one specific conclusion. Something invisible, incredibly compact, and millions of times heavier than our sun sat at the center. But calculating a mass was one thing. Proving what that mass actually was would be another. Using Kepler's laws of motion, astronomers calculated the hidden object's mass with startling precision. It weighed in at roughly 4 million times the mass of our own sun. Yet all that mass was crammed into a region smaller than our solar system. No known star, star cluster, or exotic object could explain that kind of density. There was only one explanation left standing: a supermassive black hole.
This wasn't just any black hole. It was the anchor point of our entire galaxy. Nearly every star in the Milky Way orbits this invisible mass over vast stretches of time. In 2020, the Nobel Prize in Physics recognized this discovery as one of the century's greatest.
Reinhard Genzel and Andrea Ghez shared the prize for proving a supermassive object existed there. Roger Penrose shared the same prize for showing black holes were a genuine prediction of relativity. But even with the mass calculated, no human being had ever actually seen this black hole. A black hole itself emits no light, making direct observation seem almost impossible. Scientists needed a different strategy, capturing not the black hole, but its shadow. Around it, superheated gas swirls at incredible speeds, glowing brightly before vanishing forever. That glowing ring could reveal the black hole's silhouette if astronomers could resolve it. The problem was scale. Sagittarius A appears smaller in our sky than an orange on the moon. No single telescope on Earth was powerful enough to resolve something that impossibly small. So scientists devised an audacious plan: turn the entire planet into one giant telescope. They called it the Event Horizon Telescope, a global network spanning multiple continents. 8 radio observatories, from Antarctica to Spain, would work together in perfect synchronization. Each telescope captured data pointed at the exact same target on the exact same nights. Atomic clocks synchronized every observation down to fractions of a billionth of a second. The data collected was so massive it had to be physically flown, not transmitted, to processing centers. Hard drives weighing hundreds of pounds combined traveled from observatories scattered across the globe. Scientists then faced years of painstaking analysis, piecing together an image no human had ever seen. Sagittarius A proved far harder to image than expected, even for this powerful global network. Gas around it swirls and flickers within minutes, changing faster than the telescope could easily capture. Researchers compared it to trying to photograph a hyperactive subject using a long camera exposure. Meanwhile, a separate breakthrough gave astronomers new confidence in their approach.
In 2019, the same Event Horizon Telescope project released the first ever image of a black hole.
That black hole, in the galaxy M87, was far larger and far more distant than our own. Its glowing ring matched predictions from Einstein's general relativity almost perfectly. If the method worked for a black hole 55 million light-years away, it might work closer to home. Encouraged, the team refined their algorithms specifically to handle Sagittarius A's rapid flickering behavior. They also gathered new observing data using multiple imaging techniques, cross-checking every result independently. 4 separate research teams worked in isolation, each building their own image from the raw data. This blind approach prevented bias, ensuring nobody's expectations shaped what the final image would show. Remarkably, all 4 teams produced strikingly similar results: a bright ring surrounding a dark center. The consistency gave scientists enormous confidence that what they were seeing was real, not an artifact. After years of analysis, the team prepared to reveal what they had found to the world. On May 12, 2022, astronomers unveiled the first ever image of Sagittarius A. The picture showed a glowing, asymmetric ring of light wrapped around an unmistakable dark shadow. That shadow was the black hole's event horizon, the boundary beyond which nothing escapes. Despite being 4 million times more massive than our Sun, the image matched theoretical predictions closely. Einstein had predicted this exact shape over a century earlier, using nothing but pure mathematics. Astrophysicists compared the moment to finally seeing a face, long known only through its shadow. The image confirmed what decades of stellar orbit tracking had already strongly suggested was true.
Yet Sagittarius A behaved differently than its cousin in galaxy M87 in one striking way. Despite being far smaller, its surrounding gas flickered and changed within mere minutes of observation.
That rapid variability made this image dramatically harder to capture than the one in M87. Scientists now had direct visual proof of the object anchoring our entire galaxy together.
Every star humans have ever seen with the naked eye orbits this invisible gravitational giant.
Our own sun completes one full orbit around it, roughly every couple 100 million years. The last time our solar system completed a full orbit, dinosaurs did not yet exist on Earth. This black hole has silently shaped our galaxy's structure for billions upon billions of years. And yet, compared to some supermassive black holes discovered elsewhere, ours remains remarkably quiet and calm.
Some galactic centers blaze with radiation as matter violently feeds their central black holes. Sagittarius A barely feeds at all, consuming only a trickle of gas and dust.
Scientists still don't fully understand why our galaxy's black hole stays so unusually dim. That mystery alone continues driving new research into what truly happens near its event horizon. In 2018, another remarkable test unfolded as the star S2 made its closest approach yet. The gravity collaboration at the European Southern Observatory watched with unprecedented precision.
As S2 swept past the black hole, its light stretched and reddened exactly as relativity predicted.
This gravitational redshift confirmed once again that Einstein's century-old equations still held perfectly true.
Every test thrown at Sagittarius A seems only to strengthen the case for general relativity.
Scientists now watch this black hole not just to confirm physics, but to search for surprises. Occasionally, Sagittarius A flares dramatically brighter, for reasons researchers still don't completely understand. Some flares may come from gas clumps falling in, briefly lighting up before they disappear forever.
Others might reveal magnetic processes twisting and snapping near the very edge of the event horizon.
Each flare offers scientists a fleeting glimpse into physics under the most extreme conditions imaginable. Researchers hope future observations will capture these flares with far greater clarity and detail. Plans are already underway to expand the Event Horizon Telescope with additional observatories worldwide. A next-generation version of the project aims to capture actual movies, not just still images. Imagine watching gas swirl and twist around a black hole's edge in real time. That goal remains a future ambition, not yet achieved, but actively pursued by researchers today. Space-based radio telescopes may eventually join the network, extending its resolving power even further.
Such advances could reveal whether Sagittarius A hides a jet, like many other black holes do.
So far, astronomers have found no confirmed jet blasting outward from our galaxy's black hole.
That absence itself remains one of the enduring puzzles surrounding this quiet cosmic giant.
Perhaps the jet is simply pointed away from Earth, hidden entirely from our line of sight. Or perhaps Sagittarius A simply isn't feeding enough material to launch one at all. Either explanation would teach scientists something new about how supermassive black holes actually behave. What began as strange radio static in 1931 became one of astronomy's greatest solved mysteries.
It took nearly a century of persistent observation to finally see what was always there. Two competing research teams, an ocean apart, ultimately proved the same extraordinary truth together. A global network of telescopes turned an entire planet into a single cosmic camera. And Albert Einstein's equations, written long before anyone imagined this discovery, held up perfectly. Sagittarius A remains roughly 26,000 light-years away, forever out of reach of any spacecraft. At the speed of today's fastest probes, reaching it would take far longer than human history itself. Yet in a real sense, we've already reached it, simply by learning to see its shadow. Every night, the center of our galaxy quietly anchors billions of stars in careful orbit. Our sun, our planet, and everything we've ever known circles this same invisible point. We are, in the most literal sense, orbiting a supermassive black hole right now. That thought alone reframes humanity's place within the vast structure of the Milky Way. We are not just observers of Sagittarius A, but we are permanent residents of its domain. Scientists will keep watching, waiting for the next flare, the next flicker, the next surprise.
Each new observation adds another piece to a puzzle nearly a century in the making.
The black hole at our galaxy's heart has kept its secrets patiently for billions of years. But piece by piece, generation by generation, humanity keeps prying those secrets loose.
And somewhere out there, roughly 26,000 light-years away, it's still quietly watching us right back.